Hey everybody, this is Larry. This is me going Q3 of the weekly contest 433. Competition with max min differences at most K. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this one. Apparently a lot of people got this one, but honestly, unless you have a lot of experience with just leak code problems, I think this is kind of difficult. I think this should have been a hard. I think most people would, I'm able to get it because LeetCode has just been giving us a lot of similar problems. But I think in concept, this problem is tricky. I think the first thing that you can do though is try to figure out an n square solution, right? N is going to be 5 times 10 to the 4th, so n squared is going to be too slow, but I think that's a great way to start. And what would an n square solution look like, right? Well, let me bring up the drawing board. And I think also, if you're doing dynamic programming, the n square solution you should know how to do in any case. But the idea behind the n square solution is just that, so you have some number, let's just say, or some series, putting random series, right? The idea is that, okay, for every number, going from left to right, for every number, we can just count how many partitions can we make, right? And that's just simple thing-ish, right? So for example, if you had the number 3, how we can go 3, 1, this could be a partition, and in this case, then you just add it to the number that here, or the count of, like in a dynamic program way, the number of count that ends at 3 is just equal to the number of count that begins at this sequence plus the fact that this could be a partition, or this 9 plus this partition, right? So maybe another way that you can think about this is, at this 3, if 3 itself it could be a partition, then you just kind of have two things. I mean, this isn't one partition necessarily, this is the count, right? So the left box has the count of things that ends at 1, and then here, if you could partition it here, then now you want the count of things that has only 9 and 4, and then just 9, and then you kind of sum it up, right? So then now, this box of all of the number of numbers that count includes 9, 4, 1, 3 is just the sum of these 3 possibilities, right? Because yeah. But that assumes, of course, that these numbers can be partitioned. For example, if k is equal to, I don't know, 2, then now this is not possible because this partition is not possible. So then now you just only sum up these two, right? Okay. And if the question asks you for this in n square, then you're actually mostly done, because here you can just do a for loop, right? It's going to, for each index, there are n components to the left. So that's going to be n squared. You just scan to the left, you count the max, you count the min, you stop when the max and the min gets too big, right? And then you just do some basic dynamic programming by counting the way that we just showed you on screen, right? Okay. So that's a basic part, and I say basic because you definitely need to be really, you need to be able to come up with that to even attempt the next part. You need to be strong enough to really understand it. It's okay if you don't get an AC because it's going to time out, but see if you could implement this in n squared before we go to the next step of getting it a little bit faster, right? Okay, right? I'll pause for a second, and also while I drink my water. But yeah, pause, do the n square way, unless you already did it, then we'll go on. Okay. So reducing this thing from n squared to O of n, or at least not n squared, maybe n log n if you want to, requires a few things, right? First, the way that I think about these problems is that I call these a contribution problem. Maybe you could think of it as sliding window or whatever, but I think about it as contribution because I think, okay, let's say we go from left to right? Same thing here. We're at the number 3. How far can I go back so that I can calculate the contribution of 3? 3 being the last number in a subarray, right, or in a partition or subproblem or whatever, and what is the answer. Very similar to, I mean, it is dynamic programming, so that idea is very similar, right? And for this one, we can take advantage of mono max Q and mono min Q, right? Because here, and I'm not going to go over this detail too much, only because the video is long. It is 2 a.m. My apologies, but I do urge you to look up mono Q. Specifically, the max version and the min version, because then now, the idea here is that, okay, we have a window, right? And when we extend, let's say we calculate the let's say k is equal to 3, and so here we know that this is going to be our range that we care about in a sliding window kind of way. So then now we want to extend this by, this is a sliding window, we extend this to include 7, but then now, well, 7 is the new max and the min is 1. That means that, well, the range of this the segment is going to be 6, right? Or yeah, the delta is going to be 6. So then now you start removing numbers. So you remove number, it is going to be 1 and 7 still, so it's going to be too big. 3 and 7 is still too big, and then now you have 7, and now you're good. And then now this is how you get the and then now, because you know that you're only able to construct one partition of size with only size 1 with only the 7, then now you only do a DP on here, right? I know I'm not probably there are probably a lot more details I can go into, but I'm not trying to make this into a 2-hour lecture. But yeah, but basically the idea is that with mono Q and max min, you are able to do these operations in all of one time, meaning that you're able to get the max and the min very quickly, so you could kind of do the shrinking very quickly, right? But it's not super necessary if you're careful. If you're careful, you can actually also use a heap, right? Of course, then now this is log n instead of O of 1, but that's okay, because that gives you a complexity of O of n log n instead of O of n, but that's going to be fast enough for you to solve. And I think, honestly, if you don't want to understand mono Q, and that's fine, right? I didn't understand mono Q for a long time. I would say try by using the heap method. And then here, of course, you still need both max heap and min heap, right? And then, like, to go over it again, the idea behind that is to get the delta of a segment, right? Here we know that the min is 1 and the max is 7. But if you think about it as a min heap and a 1 max heap, we just go, okay, well, we have a min heap. What is the smallest number? Well, it's going to be a 1. Okay. Right? And so, and then we get the max heap to get the max number. Maybe not the max heap, actually. But no, I guess it is the max heap. But yeah, I mean, of course, you have to do this in a lazy way so that you can remove stuff later. But that's basically the idea, right? Is that as you shrink your window, you can't figure it out. And okay, and the thing is that, okay, let's cut back. Let's say k is equal to 6 for now, right? Let's go back to 6. So your window is actually here. What does it mean for this to be window? This window just means that given the number 7, we can choose any partition inside of it, right? Meaning that 7 can be a partition, 7 could be a partition, because by definition, this is less than 6, or the difference is less than 6. 137 is a partition. 4137 is also a partition, right? So that means that we have all these. And of course, as I said in the math, in the DP, is just 7 plus the answer of this prefix. This is 73 plus the answer of this prefix, this and so forth, right? And so then now, you're basically trying to get the answer of the sum of this chunk, whatever the number of count of sub-arrays that ends here, plus this, plus this, plus this, right? And with that, this is where you use one of the two things. One is prefix sum, right? Because then now you can just construct a prefix sum on top of this, because now you can kind of look at this. Let's say you store this range in a number cell here. This range, we count from the first element will be 0, right? So you just store it here, and then so forth, right? So then now this is how you get the prefix sum in this way, by summing up all the previous chunks, right? So let me change the card real quick. So then, so in a way, this cell is just going to be this chunk. This cell is going to be this chunk, which is, of course, just this cell plus this cell. And then this cell is going to be this chunk, which is just this cell plus this cell, right? And so forth. And that's basically the idea. Like I said, honestly, it is not a easy problem or a medium problem. I think this is a hard problem, but I think it's just that with LeetCode, we've done so many similar problems that a lot of people understand it. But if it's new to you, you may not understand it because it's a lot. And honestly, even the implementation is a little bit tricky. So like, unless you have a lot of practice, you may take a long time implementing, even if you get all the ideas that I said. So definitely give yourself a little bit of leeway and breathing room, and just do it slowly. It's fine. Yeah, but this is basically my code. Not gonna go over it in super detail, we'll go line by line, but I'm not gonna go over a lot of the understanding. But basically here, left is the left side of this left side of this sliding window. We have the max Q. We have the min Q. Get the max element of the window. Get the min element of the window. And then this is DP. DP, we should define it, right? Why is my space not working? DP sub I is equal to the number of partitions. Is it partitions, right? Yeah. That ends at I. Technically, I think it's I plus 1 is the way that I set it up. Because the reason why I set it up that way is because DP sub 0 is equal to the number of partitions that is no set, right? No set, so, and there's only one way, right, which is what we set it up. And then DPP sub I plus 2 is equal to the DP I plus 1 plus DPP I plus 1, right? So this is just I define this recursively is basically prefix sum of the DP sub 0 plus DP sub 1 plus DP sub I guess dot on the outside, plus DP sub I, right? I think this is I for I plus 2. Again, so yeah. That's basically the idea. And then, yeah, for each number, to kind of make it sliding window, I didn't think of it as sliding window during the contest, but we can think about it, so I want to write it as right. So then now how far can we go back? And I guess we don't even really use I anywhere. I mean, here, I suppose. Maybe I is a little bit better for this stuff. But yeah. And yeah, you could see me double checking my work with a for loop, but that's what this thing does. Let me quickly submit it so that I know that my rewriting doesn't is not so bad. Okay, it is so bad apparently. I thought I didn't use it more, but I don't know why does it go away automatically by itself? I didn't click it. I just click on this and then it just goes away. LeetCode is so silly. But okay, so that's still good and it automatically goes away. So there's a weird bug somewhere. But okay, anyway, yeah. So this is the prefix sum of the DP thing. Maybe I could actually most of the time I could PDP for that reason, prefix sum of the DP. I don't know what happened to me to do that. But these are the base conditions. Like I said, no set has to be as one count. And then here we go, okay, we increment the sliding window, how far can we go back? Well, this is, like I said, I'm not going to go over max Q or min Q on the mono Q for this problem. I do it in a lot of videos, but today I just want to keep it a little bit focused on the DP part. But this is part of that. This is so that we get rid of numbers that are not possible to be max numbers in the future. So that's why your max Q. And here, Same thing for the min. And then the delta is just going to be, and I guess delta, we could just put this here. Maybe this is fine actually. It's a little bit less confusing. But basically the delta is the max Q's value minus the min Q's value. If this is greater than K, we want to shrink the window on the left side. And then if the index is equal to left, then we pop on the max or the min, shrink the window, update delta, and we're good. Right? Yeah. And here we're trying to sum, oh, this is not quite right. Right? Sum from left to right minus 1 inclusive. Of course, that's why I defined these so precisely, because this is plus 2, right? So that's why the right minus 1 inclusive is just dpp right plus 1 minus dpp of left, keeping it, because we want to include left, so it's going to be left minus 1 is what we want to do. So that's basically the answer. Maybe I'm off by 1, I don't know. But yeah, and then we just remember to mod, update dpp, to collect, the things, and that's it. And then we take the last value, which is all the sum of all the partitions at the last element, and that's it. What's the complexity here, right? Like I said, I mean, I'm going to hand wave you a little bit if you don't know MonoQ and sliding window. So between the MonoQs and the sliding window, it actually is amortized all of 1, because each element can only be popped or pushed or popped from either end at most once, right? So therefore, it's going to be linear time, linear space, and that's all we have for this one. Here's the top, in case you're wondering. Here's the loop, most of it. Okay. Make it shrink a little bit so you can get all the loop in one screen, mostly. And in the end, just return the last element. And that's it. That's all I have for this one. Thanks for watching. And yeah, you could watch me attempt to solve this during the contest now. That would have been, not so dumb. But today I am a dumb boy. So, alright, let's go. Competitions with max min differences at most K. Okay. Can't believe I have a typo on that one. That is just silly. Maybe it's a good thing I don't do these contests anymore. It's so frustrating. Anyway, okay, let's start. You're given an integer array nums and a K. You partition nums into one or more non-empty contiguous segments such that in each segment, the difference between the maximum and the minimum is at most K. Okay. Turn the number of ways. N is, what's that, 50,000? 50,000. N squared is trivial, I guess. So then it's just like a MonoQ thing where, okay, this is 3, and you sub over the thing. Okay, so it is kind of like DP, but how is this a medium though? That's such a hard medium, I feel like. Maybe not. Maybe I'm thinking about it the wrong way. But okay, let's do an N squared first, and then we'll think about it. Right. So N squared will look like this. Okay, so here we go. How far can we go back? And that's through a MonoQ, right? Because then now this is just a mono stack, so it's max Q, and then a min Q. I think people probably have template code for this. I'm gonna write it out. So let me start. Okay. While length of max Q is greater than 0 and max Q, the last element is smaller than, okay, x is 0 to num sub I, right? X, then, or if it's equal to, then we go back, right? Yeah. Then mxq dot pop right? Kind of. We also want the index, so we do that. So then now we do mxq dot append index I and x, right? Well, length of m and q. I'm just laughing because of the silly problem that I had last in Q2. I don't know what I'm doing. Okay, right. Same thing. Okay, right. So then now we go. So the max number is going to be max q of 0 minus min q of 0. So that's going to be the delta. So while delta is greater than k, then now we pop from the front, right? Okay, yeah. Then now, if mx, oh, this is of 1. So then now, if the index is less than on the min side, on the max, oh yeah, if the index is early on the max side, then we do a pop left here. Else we do a pop min. I guess you could pop both as well, actually. So maybe we have to do a check for it. And then else, so they equal, so then we pop left from both. And the invariant is that this will always terminate before it runs out, because then now delta will be 0, right? Delta is mxq 0, 1 minus, right? Okay. So then now delta is 0, so then that's how far you can go back. And then now, so then that's how far you could go back. So then you just count the sum of those things. So then now you have dp is equal to 0 times n plus 1, say. And then you have now, I don't know, I call it dpp for prefix sum for whatever reasons, but so then yeah. Okay, so then now we want the sum from the min of mxq0. So that's the index in which the last number is in the, it's in the range. Okay, so yeah, min of these is going to be the furthest, right? To I, or I minus 1 maybe. So then now we have, in theory, you would write something like dp sub I do. So you have like for j in range from this number to I minus 1 technically, dp sub j. But now you would write the dynamic programming part, so that would be dpp of, I'm gonna get the index so wrong, but that's okay, maybe. We'll see. Very likely to get index wrong. This minus 1? No, it's well, no, it's minus 1, but this is this plus 1, so this is this plus 1, and this is also plus 1. And then now, or maybe this is just I. No, this is confusing a little bit with the prefix sum in things. And then now, dpp of I plus 2 is equal to dpp I plus 1 plus dp of I plus 1 for things. And then now we just return, well, that's the number of count from all those things, yep. And then we just want to return dp of minus 1, return mod. And we have to do mod stuff along the way, remind me. Okay, well, 0 is not going to be Gucci because we don't have 1. we have to set dp of 0 is equal to 1, and as a result dpp of 0 is also 1. No, we want this to be 0. dpp of 1 is equal to 1, I think, to calculate the prefix correctly. 6 is fine. 1 is obviously not. We need to mod some stuff anyway, so let's do that before I forget. I mean, that's not the reason why this is failing, but alright, it was 334. I have one partition for k is equal to 0. Alright, well, I mean, that's a good case to debug actually. So let's take a look at the array. So that's going to be one way. Okay, so there's one way. So the 3 goes all the way to the left, so there's one way. That sounds reasonable. This 3 though, there's 2 ways, right? So it's going to be 1 and 1. I don't think I set up the sentinel values correctly, maybe? No. It's roughly right, but it's not. This should be 2, and then this should add to 2, right? Alright, for now let's ignore this, and then we do. Alright, let's see if that works real quick. Nope. No, I mean, this should be right in idea. DPP doesn't make sense, but that's fine. Okay, so this is the last index, so it's gonna be this -1 maybe? Maybe that's why I'm like a little bit weird. Does this go to like -1 and never infinity or something? I don't know. Why is this taking so long? Maybe it just does long. Okay, but still not right. This shouldn't be 0. Okay, well, let's print out what this is doing. This is so annoying. Well, like, I'm so bad. That's why it's annoying. I feel like this is basically done, but I'm just dumb. Okay, so 0, 3. Yeah, okay, so 0, 0, 3, that's fine. So then now we want there should be to -1, but this is just +1. I think that's why I messed up. I actually meant to do that, but I forgot. Okay, so this is still 6, okay, and this is 1. Not so great. 1, 1, okay, I see. So then actually this is where I was wrong with the equal sign actually. Okay. I actually was thinking about this, but then I think I was wrong on the tie breaking. Okay, so that looks okay. Of course, this is now going to be too slow, so then now we want to wait. Where did I have it? Did I just erase it? Oh, no, it's this one. Okay. I was like, why would I erase that? Okay, 62, 62. All right. Let's YOLO submit. Am I confident? Not at all, but that's fine. It's fine. Okay. Well, it's a little hopeful though. But okay. So we have 3. The answer is 4. What's this? K is 6. So that means that you have. I just print it out. Actually, I don't have to guess. 1, right, and then 1. That's fine. 13 could go to yeah, that's fine. Yeah, and this is 3. I guess that's less fine. So yeah, was this and this? Oh wait, no, it's still no, but 12. It should actually go all the way to the left. So I think maybe that's where I have an issue. Because here. I say 1 for the max and then the min. But the max and the min does not extend through the max and the min, right? Okay, yeah, I think that's where I'm wrong. I'm popping too aggressively here because I always I skipped all the numbers because I go to the numbers to the, okay, fine. I'm just being dumb. Okay, so then maybe I just do left is equal to 0, and then now we increment left by 1. So then if mxq00 is equal to left, if mnq how's this a medium though? I mean, I don't think it's hard, but it's not, I don't know, shouldn't be that easy. Okay, right, so then if you increment, okay, and then now this is going to be this, and then this is going to be left plus 1, so it goes to the, not the previous one, but the either left or left plus 1. Let's see. Alright, 624, that looks okay, because I removed the numbers to the right or to the left of, to the left of the index I'm caring about. And I'm still printing stuff. Okay, here. 624, YOLO submit. Come on, please. Okay, good. I was a little bit aggressive on that pruning. Alright, how am I doing? Alright, not so Gucci because of a lot of wrong answers today. Today is a very bad wrong answer day. But thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this contest, this video, these problems, everything in between. Stay good, stay healthy, do good mental health. I'll see y'all later. Take care. Bye bye.